Invent a Nastran, you can do more than just one analysis. And when you're doing, say, for instance, you do your first analysis, you can take the results of that analysis and put it into your second analysis. So when you're doing things like, a heat analysis, so thermal stress, what you'd first do is you set up your thermal conditions, heat flux, convection, initial temperature load, and then you run the simulation. Once that simulation has been run, then we can take that analysis or the results of the analysis and put it into another analysis that we've created, your thermal stress analysis. So this is just one of the tutorials that I found that Autodesk has put out there. And I just find that it's quite nice that, if you haven't seen, if you're going through tutorials, it's quite nice to see how something is done. So I'm just going to quickly run through this. So first of all, when we do create our first analysis, it's a nonlinear steady state heat transfer. You'll see over here, I've got a linear steady state heat transfer as well as a nonlinear transient heat transfer. Once that's done, make sure that you've got your output set for your nodal and your elemental your objects. Once that's done, we go set up the loads for this. Now you'll see there that the arrows pointing off a little bit different. So you'll see there's like a little square on it, tells us that it's a heat transfer. I think it's not like a direct force or pressure that's being put on there. So once that's done, we can set up our load. So this is the flux, the thermal, your flux load. And if I go to my loads over here, I'll just show you how you'll set this up. And that flux load will be positioned on the inside. So under over here, you'll see that I've got my heat flux, and that heat flux then is selected or applied to these inside faces over here. Once that's done, the second one we've got is our convection load. And your convection load over here, it needs two different load definitions: your ambient temperature as well as your convection coefficient. Ambient temperature, the normal temperature of the air around you, and then your convection coefficient, and that then is applied to all these surfaces over here where it's going to conduct that heat. Then the last one is the initial temperature. So with that over there, we've got the initial condition. And with your initial condition, because it's a nonlinear steady state heat transfer analysis we're doing, it'll show you that the subtype is temperature over there. And then your load definition. So once that's done over there, I've set that up and I've run the simulation. With the simulation, I can just go and load up my results. So what Inventor does do is, it doesn't have the results initially loaded up, as it just tries to save a little bit of RAM and space. So to go and see the results, right click and edit. It doesn't do any automatic plots over here. And you'll see now then the deflections and the stresses that are being put on over here. So you'll see there for my sub cases, it's worked out that load over there. The result data is my thermal, and it's my total heat flux. And to display it, just select on the plot button on the left over here. So this might take a time, so just be a little bit patient. And there we go. And so we can see there the heat flux with just those initial load temperatures. Okay, so you can see your maximum is 0.133. Okay, so once that's done, and I will then go and create a new analysis. And this will then be a linear static analysis using the results out of this analysis over here, my nonlinear steady state heat transfer analysis. So I've set it up over here. Just activate that. Normally I just go right click on the part and say new analysis. And then I can start putting on my different loads. Okay, so with this over here, you'll see there I've put down some constraints. So those constraints over here are what's holding the manifold together. So I've selected all the little, all the bolt holes over here just to put them down. You could put connectors on there as well, bolted connectors if you wanted to. Also be modeling the bolts with maybe a pre-tension on there as well. Once that's done, then I'm going to do this temperature load over here. And to do a temperature load, you're going to go to from results. So I will go over here and I will say, right, I'd like to do from output. And then from that output over there, I'll actually go browse to my to where this the results have been saved. Okay, so it's under my manifold, InCAD, FEA, and there you can see there are my results. Okay, so that result over there, click on open, and then you'll see there you've got your output set. So there we go. If there was more than one subcase, you could choose any one of those subcases over there to add on to the loads that you're now putting in this analysis as well. So once that's done, we run the analysis, and you'll see there I will now have my my stresses. So just go right click and edit on that stress plot, and we'll see there, if I just go plot it, the stress and what that stress actually is at the top over there. Now it'll go show me my color map. So just while that's going, so you can see here now how you're able to take the results from one analysis and then go and use it as an output in your second analysis as well. So you can see there are the stresses that are being exerted on this manifold due to the heat that is being generated when the engine is actually running. And that's how we can take the results from one analysis and put it into a second analysis. Thanks very much for watching.